Hi guys, hope you're doing well. Welcome to the video. Well, as you can see from the video title, this video is going to be about how we can create Gcode from PDF plans using free software. Now, if you see my recent video on this machine here, where I converted to use the CNC needle cutter, I did say that I wasn't going to cover actually creating the Gcode files because it would have made the video far too long. So that's basically what this video is going to be about, is how we can go from a PDF plan to a Gcode that we can run on this machine. So I'll just give you a quick overview of what we're going to cover in the video. So just before we do that, there are other ways to do this. This is the process I found works well for me, using the software that I know the best. So I'm sure you could do this with other softwares as well, and and if you prefer to use other software, it might give you the sort of the technique of how to do it. So what we're going to cover, I'll just get me notes here, make sure I haven't forgotten anything. So the first thing we're going to do is we're going to look at the software required. So then we're going to see where we can get the PDF plans from. Now, I've used a few places in the past, and I'll show you some of them as well. And the type of plans, we need to get what's called an untiled version of the plan, but I'll discuss that as we go further into it. Then we use a vector graphics program called Inkscape to get the PDF plans a bit more cleaner, so we can remove things like images and text that we don't actually need for the Gcode. So once we've done that, we'll save the file in what's called DXF format, which is a CAD format. And I use Fusion 360 for this, but you can use other software for this. And we'll load it into Fusion 360. And then what we have to do then, as you'll see, we'll need to check the scale, and we'll probably end up with some gaps in the so the lines won't be joined, but we'll explain that as we go on. And then we'll fix them gaps, modify the file if we need to add extra parts or sections on there, and then we'll create the new DXF files. And then once we've done that, we'll load the DXF into OpenBuild's CAM, and we'll generate the Gcode and then show you the Gcode running. I'll show you a bit of video from the previous video of it actually working, rather than do it all again in this video, because I'm getting a little bit short of Depron foam. So if that sounds interesting to you guys, stick around and we'll go on to the first section, which we're going to look at the software required. So guys, in this next section, what we're going to do, we're going to have a look at the software we need to convert these PDFs into Gcode. Now, the software will work on Windows and Mac, and some of the software will work on Linux. So Fusion 360 doesn't work on Linux, but it will work on Mac and PC. So I've got a Windows machine here, and I've also got a Mac machine, and it works on both. So the software we're going to need, the first one is called Inkscape. Now, if you've been in the RC hobby a while, you probably have already heard of Inkscape. But Inkscape is a let me get the, there we are. So that's Inkscape website, and you can download Inkscape for whatever operating system you've got. I said this will work on Windows, Mac and Linux. So I've just downloaded the latest version, and I've already got it installed, so I'm not going to go through the install process, so I'm sure you know how to do that. So just get the latest version of Inkscape and install it on your machine, and that's part one that we need. The next thing we're going to need is Fusion 360. Now, I've already got Fusion 360 installed on my machine, and you might notice up in the corner there it says expiring in 4 days. Now, this is the free version, or what they call the hobbyist version of Fusion 360. Now, there are a few limitations with it, but so far there isn't any I've found that cause me any problems. But with it saying expiring in 4 days, what happens is when it actually expires, what you have to do, you just have to re-register every year, and then you have to download the software again, and then re-register using your account you already had, and then it comes back up. I've already done this last year when it expired, and there was no problems with it at all. It sometimes takes a little while for it to re-register, so you go back onto it and it'll still say expired, but then they do say it can take up to 30 minutes. So that's the second piece of software we're going to need, and that and Fusion 360 will only work on Windows and Mac. So, and the other piece of software we're going to need is OpenBuild's CAM. So I've already got it on here, but I'll go to the just cancel that. So this is the OpenBuild's CAM software. This is actually runs online, and I think it's brilliant. And so what we do is once we've got our files manipulated in Fusion 360, we then load them into here, and then you can see there's an option there that says generate Gcode. So that's what we'll be doing with that. So they're the three pieces of software that we're going to need, and they're not the only software you could. I mean, for Fusion 360, you could substitute FreeCAD. Now, I've had a little bit of a look at FreeCAD, and I just don't have the time and also the motivation to learn another piece of software. But I'm sure you could do this with FreeCAD as well. You know, there's probably some clever guys out there can say there's a much easier way to do this with FreeCAD. But so if you do know of any other ways, just let me know as well. So that's the software we're going to need. So what we'll do is we'll move on to the next section where we'll look at where we get the PDF plans from and what we need to look for in them plans. So guys, in this next section, what we'll do is we'll have a look at the PDF plans, where we get them from, on the type of plans that we need to get, because there's basically two types. So I'll show you them. Now, the sites I've got PDF plans from in the past, the first one I ever got some plans on was a site called RC Powers. Now, the guy that used to run RC Powers, called Dave Powers, he's actually stopped doing this now, but the site's been taken over and is run by FRC Foamies. So if you go under the FRC Foamies forum, you'll get a link to RC Powers, but I will put all links into the description as well. So if you go onto the JetWorks Online, if you go to their store, and then they've got all sorts of planes there you can download plans for. So if you go, so you can see there is a small charge for the plans. So once you've paid for your plans, you can download them then. Now, so that's JetWorks Online. FRC Foamies is the same. So you can see there's some quite good ones here on FRC Foamies. If we look at SU27, you do an add to cart. And I think the way FRC Foamies does it, they just ask you for a donation. There's a minimum amount, but it's up to you what you want to put in there. So I've actually built the F18. You may have seen it on one of my other videos. Yeah, so I built the F18 a while back. I'll put a picture of it as well because it came out quite well. It's in the repair shop at the moment. And the other place you can get plans from is a Flight Test. Now, Flight Tests, their plans are usually free. So that's what a lot of guys use. They use the Flight Test plans. So you can use them as they do take a bit of finding. That's the only thing with the Flight Test site, because I think they like you to buy the already cut laser plans. And some time ago, I did have one of their kits, and it was all right, but it was a little bit expensive by the time you pay for the shipping and the import duties and that, you know, for what it was. But it was a good little flyer. That was the Bushwhacker. So that's one place you can get them from. And then the other thing, there are quite a few free ones. So if you just put a search in PDF plans, RC planes, you'll come up with quite a few. Now, what you need to look for is when you get your plans. Now, this plan for this MiG-29 I purchased several years ago, and you can see you can get it in two versions. So this is what's called the tile version. So the idea behind this is you print this off in your inkjet printer on a sort of either A4 or the US size, which I think is 8.5 by 11, I think. And then what you do is once it's printed off, you stick them all together. So as you can see, there's all the plans there. Now the other way to do it, and a lot of guys do this as well, you can take this plan to a print shop and get it printed out full size, and you don't have to join all up together again. So what you need to do is when you are looking to download a plan, make sure they've got an untiled version. Now you could use one of these, but you'd have to convert it all, then you'd have to stick it all back together in a CAD program, and it would be a lot of work. But if you can get the untiled version, then that's the one that we use within Inkscape to get our lines out. Now as you can see the plan, there's a lot of extra pieces in here that we're not going to need. So that's the reason we put it into Inkscape. We get rid of all these unwanted objects, and then what we can do, we can save it in a format that we can use in Fusion 360. So I'll put links down to where I get my plans from, and then you can have a look yourself. Just one word of warning, guys, I won't be making available any of the DXF files or Gcode for any of these plans, out of respect to the guys that have taken the time to do this. You know, if you can't afford one, then there's quite a few free ones around, so just do a search for a free one. But they're not a lot of money anyway, so you know, support these guys and pay a little bit of money and download the plans. So what we do is go on to the next section now, where we'll look at how we get the PDF into Inkscape and then get rid of all these unwanted objects and save it in a format we can use in Fusion 360. So what we're going to do now, guys, is look at Inkscape. So hopefully you've managed to download it and install it okay. It's quite a straightforward install, and as I said, I'll not go through it with you because it's fairly straightforward. So I've already got Inkscape installed on my machine here. So what we'll do is we'll load up Inkscape, and hopefully you've got a PDF plan that you can use as well. So now when you first install Inkscape, you haven't got it installed already, yours may look a little different to mine, because I've just gone in and changed a few things for my preferences, like the theme. So you can either have this dark theme or a light theme as well. So first thing we need to do is open our PDF. So what we do is we'll go to an Inkscape will open loads of different files. What's quite often useful is just to go down and select PDF document. You haven't got as many to look at then. So if we go in and bring the MiG-29 untiled PDF and we do open, and we come up with this dialog box. Now if you've got more than one page, you can tell it which page you want, but then what we do then is we go and basically I leave all the defaults. The only thing I take off is embedded images. Sometimes it gets rid of them, other times it don't. You know, it just depends on the file. So just because we don't want the embedded images, and we say OK. And there we are, we've got our PDF in. So as you can see, we've got lots of things in here that are not going to be any use to us for creating Gcode. So what you'll probably find is this is all grouped. So if it may be on this, let me just double check. So if we just go on to and select, no, this one isn't actually grouped. What you'll find on some of these files is that they're grouped. So if we just do a select all, I think I've probably used this, I've saved this file like this before, but what you'll probably find is you'll only have one object in here and you'll not be able to select them individually. So what you have to do is go on to object, so select everything, If you do a select all and then go up to object, or you can get it from one of these little icons here, but if you go to object and there's an ungroup there, and what you need to do is keep doing that ungroup until the number at the bottom doesn't change. So if we have a look there, so we just do select all again. See at the bottom there it says 139 objects. So what we need to do is get rid of some of the objects we don't need, and the sort of things that we don't need are like this image here. So you can sometimes just do a selection box, and then if just do delete, and we don't want that. And basically what we want to do is go through everything that's not going to be of any value to us. So we don't need the text, and this section here we don't need, and these numbers here we don't need, and there's some, if we zoom in a bit, I'll just zoom in with the scroll wheel, we don't need that, and we don't need any of that. So I've got rid of all of it. Now you can leave that in there if you want, where the carbon rod goes. On mine I've actually taken it out. But one thing we do want to keep, if we look down at the bottom here, we've got a scale. Now we need to keep that in there, because when we go into Fusion 360 we need to check that it's been scaled correctly. So once we've got rid of all the objects we don't need, and that it could take some time to do that. So there are techniques to select objects of all the, so if you've got a load of coloured objects in there you don't need, say they're all red or something, you can select via colour, stroke and fill, and you can get rid of a lot easy that way. So now we've got that, what we need to do now is save it. Now the way I found the best way to do this is to save it as a DXF. And the reason for that is it seems to scale better in Fusion 360. In fact, when I get into Fusion 360, I don't need to scale it. So if we do save as, and then the most common format for Inkscape is SVG. And you can import that into Fusion 360, but I have found it doesn't scale as well. So what we want here is AutoCAD DXF R14. I found the R12 doesn't work very well in Fusion 360, so we do R14, and then what we do is we then save it. Now I've done this quite a few times already, so all we would do is we just save that, or give it another name if you want. So if we just save that as, I'll just call it YT on the M for YouTube, save that, and then you can see it brings up this dialog box now, and it's got a base unit of millimeters, and I think that's why it scales better in Fusion 360. So if we say OK to that, I think when you do SVG it doesn't have any units in it, or it just has points. So I've tried both ways and I've found the DXF is the best way to do it. So if we do say OK, and then we've got our PDF converted into a DXF format, which we can now use in Fusion 360 or whatever CAD program you want. Now when we get the program into Fusion 360, you'll see there's a few little problems, and so what we'll do is we'll cover that in the next section. So guys, in this next section, now we've created our DXF with Inkscape, what we can do now is use Fusion 360. Now there are other programs that you could use for this, but as I said earlier, it's the program I know the best, and you know, you may know other programs better, so I'm sure this process will, what I'm going to show you, will work in these programs as well. But yeah, just use whatever you feel most comfortable with. So I've got Fusion loaded, and what we need to do then is insert that DXF. So if we go to insert, and we've got DXF there, so we insert DXF, and I'm on the design tab here. So we're on the design tab, so go to insert DXF, and then it wants to know which plane we're going to I always put it on the top plane, which is this one here, and then we select our file then. So we go to, and there's the one we created, MiG-29 untiled YT DXF. So we select that file, and you can see what it done then. It brings it in, and it's also selected the correct units because we saved it with the units in Inkscape. It's kept that for us. So so all I do is say OK to that, and then if you have a look in sketches, we've got a sketch now called the same name as the DXF. So if we just turn that on top, and then you might think, looking at that, that looks okay. It's not okay for us yet. First thing we need to do is check the scale. So if we zoom down the bottom here, and that line there in the PDF is 2 centimeters, which should be 20 millimeters. So if we just click on that there, you can see down at the side there, it says the length of that line is 20 millimeters. So that's coming absolutely perfect. So that's the reason for using the DXF within Inkscape, because it can save in that millimeters forward. Now, if you prefer to work in inches, you could do the same in inches. So that's the other way to do it. Now, on the face of it, this PDF looks all right. But if you used Fusion 360 before, to do most things, what we need these profiles all closed. So where it's white in the middle, it should be blue. Now, if we zoom in, we keep zooming in, right down here, what you can see there, these lines are not joined, and that's why we haven't got a profile there. Now, you think, well, how am I going to know where all these lines are joined and not joined? If, you know, if I've got to go around and zoom in every section and look at it. Well, there's an easy way to do it. On the Fusion 360 web store, so if you go to Tools, and if you go to Add-ins, and you go to Fusion 360 App Store, and then just do a search for Sketch Checker. And this is what we're going to use. Now, I've already got this installed, but if we go onto it, so it's available both for Mac and Windows. And basically all you do is download it, install it. You'll need to restart Fusion 360 for it to work. So, but once you've done that, and then what I've done, let's close that down. Go back onto Fusion 360. So what I've done, go back to solid there. I've actually moved it up until on the ribbon bar, but what you'll find is if you go to inspect, you go sketch, check sketch. Now, if you try to use it now, it will come up with an error. So it says it needs to, you need to have a sketch that you're editing already. So if we do check sketch, you see the sketch needs to be active to run this command. So all we do is on the sketch, we go edit sketch. So we're now in the sketch, and I haven't saved anything yet. So let's just save stuff just to make sure we're okay. I'll just call this MiG 29 YT, MiG 229. Eh? So we're saved now. And if you look up in the corner there, it says 4 of 10. On the hobbyist version of Fusion 360, it allows you to have 10 documents open at once. Now you can have loads more documents. I mean, if you look at my design side there, I've got loads of different folders, and if I go back to the, I've got one called current, I think. I've got loads of documents, all different folders. So all that means is you can just have 10 in an edited state. And what happens is when you finish working with a document, you can just mark it as read only then. So so you think, right, I've finished with that one, I don't need it anymore. And if you're running out of documents, you just go mark it as read only. So I don't find it's a problem for what I do anyway. I know some people were a bit upset when Fusion changed the licensing laws, but you know, so far it works okay for me. So right, now this sketch checker, what I've actually done here, you can see it's up there. What I've done there, if I go onto the side, them 3 little dots, you can put pin to toolbar, and that's all I've done just to make it easier to get to. Because as you see, as we go into it, you need to reference it a few times. So we'll just zoom in a little bit more. So what we'll do now, if we run that sketch checker, now you can see all them dots there. And that's basically saying is there's a line there that isn't joined to another line. There's a gap there. So if we just zoom in, yeah, the easiest one to see is this one over here. I think the gaps are so small you can't hardly see them, but you can see it there. So we've got a gap there. So what we need to do, we need to close that gap. So the easiest way I found to do that is on the modify toolbar, is to use the trim and extend. And what you probably find, extend isn't actually on the toolbar. So again, I've gone onto that there and then pinned the toolbar to make it easy to find. So all we need to do now, if we select extend, I don't know where you can see, if I zoom in a little bit more, there we are, I might be able to see it. If I go onto there, you can see what it's going to do, it's going to extend it. And then what I tend to do is extend it even further and then do this one. And then you know that they're actually touching now, and then use the trim tool. So that's that side there, and we've got another one here. So if we do extend, and you can just see a little bit in there, extend, extend, just extend that one again. That's it. Don't worry about these warnings you get down at the side, they don't make any difference for what we're doing. And if we go there, we trim that one. And when we've got the profile closed, it will turn blue. So I think there's another one down here as well. So if we go down here, and if we do extend, it might not be that one. It might be this one over here. Yeah, it's that one there. So what you'll probably see happen is when I zoom in here, when I do, let's get it. When I click that, you'll probably see it go blue. There we go. So what we've got now, we've got a closed profile, and that's what we need to go on to the next stage. Now, it's probably going to take a little while to do that as well. So what I've done, I've created one already. Now you can see on this one here, there's a little bit of, that one's not quite touching there. So basically what we're going to do is we need to go through until we get these profiles turned blue. Now that could take some time, but once you've done it, it doesn't take very long. But what I've done is I've already created a profile. Well, I've closed all these up just to show you what we're after. So we'll load that in. If I can find the right one. So what we'll do, we'll finish that sketch. Ah, there we go. Ah, nearly all of it's done, yeah. So that's saying inch, we don't want that, we want millimeters. There we go. So as you can see on this one, I've gone through and done all these. There's still some work to do on this one here. So if we do an inspect, oh, we need to activate it. edit sketch, and then if we check it, so we've still got a few. So I think what I've done is I've left a few of these just to show you what would happen. So we go onto this one here. You can just see there's a gap there. So what we do is we do an extend on that one, and you can see it's filled. We'll just trim that little spare bit there. So now we've got our almost closed profile. So we've still got this one down here as well. Extend. There we go. We'll trim that one. So now we've got all our profiles blue now. So that means we can go ahead and use them. Now one of the other things you can do as well, as you see on this part here, I've cut the servo hole out there. So now you've got it in here, you can make some modifications. Now the other modification as well, if you have a look on this tail, I've already got the carbon rod in the back. I've gone straight across there because this original plan, what you used to do there was put some extra foam there and glue some plywood on. It was before 3D printers became really popular. So I now use a 3D printed mount for the motor mount on here. So what you can do, if we can just go on, we'll just escape out of there. So I'm just going to go delete that, delete that. I'm going to delete these two as well. And I'm just going to create a straight line from there. So now that's how I got that part there. So that's the beauty of now you've got it like this. You can make some modifications to it, and you can also see I haven't got the carbon rod in there because I tend to use my Dremel tool for doing the carbon rod on there, which if I show you on here, so I've got it across there. You see that it's starting to come together now. So I use my Dremel tool to put the carbon rod in across there, so I don't need the actual hole cut out. So now we've got all the profiles closed, we can move on to the next stage. So what we'll do is we'll look at that in the next section. So now we've got all the profiles closed. The way I go about it now is to extrude all the profiles into bodies. And you'll see why we do this in the next section. So all we need to do is select any of the profiles. Now, the reason we had to close all these gaps up, because you won't be able to select the profile, because Fusion likes to work with closed profiles. So what we do now is we just right click and we go to extrude, and then it wants to know a distance. Now the distance doesn't matter really for what we're doing, but what I tend to do is do it the same width as the foam. So which is 6mm. And then what I'm going to do is I'm going to go through and do all the bodies. So that's, we go into bodies there. So we've got all these different bodies. Now what you can do to make things a little bit easier as well, you can go in and name these. So if we just highlight it, and then if you just click into there, you can name it. So I just tend to call this bit main body, and then the other bits you can go through and name as you want. So so elevator, there's body 3, so we can call that elevator. Just makes the things a little bit easier when we get on to the next stages. Now what we're going to do for this demonstration, I'm going to show you how we get the fin section out there and the elevator section out. I'm not going to do it all because it would take quite a long time. So we'll work on these two. So what I do next is I create a new component in Fusion 360. It just makes things a little bit easier to do. So we go new component, and what I call this sheet 1. So this is going to be like on a sheet of Depron or foam board, whichever type of board you're using. So I call it sheet 1. And it's activated. So it says activate, but I think it's already activated anyway. And then what I'm going to do is I'm going to switch the bodies off up here that I'm not interested in. So I'm going to switch the main body off. I've switched the fin off, haven't I? Yeah, I want the fin. I don't want the main body. I don't want that. It just makes things a little bit easier to work with, so you don't get too confused. So what we do then is we go. So we've got it activated, and then what we're going to do, we'll just bring this up so it looks a little bit easier to see. And we're going to create a new sketch. So we use this button here, and just make sure you've got this activated so the sketch appears down here. So create a new sketch, and we just do top plane there, do everything on the top plane in this. So we've got 2 sketches there, and what we're going to do is we're going to tell it to project the geometry, and because we've joined it all up, it's going to do it as one piece. Now within the OpenBuild's CAM software, what it likes to work with is polylines, and what we can do, we can create one continuous polyline, which makes it really easy to generate the Gcode. So what we do for that is we go to create, we go to project, and what we want to do here, we've got 2 options here. Now this option here is specified entities. Let me just zoom that in a little bit more. Or we've got bodies. What we want is bodies. And the important thing here is to take projection link off, because what we're going to do afterwards, we're going to try and move these bodies closer to the origin, to 0, 0. If we've got that on, it won't let us move it. It took me a while to fathom that out. I thought, why can't I move this? And eventually I fathomed it. So what we do is we select that body, and we select that body, and we go OK. Now if we turn these bodies off back in the main component, you can see what we've got left is these sketches, and this is all one sketch. So what we could do now is just save this as DXF, but it's not going to be in the right position. So I think the way I do it is I select the fin, and what we're going to do is we're going to move it. So I'm just going to select, sorry, not the fin, the elevator, and I'm going to do move, and what I'm going to do, I'm going to straighten it up a bit, and I'm going to move it across as close to the, so this dot down here right on the looks like a centre of gravity marker. That's our origin 0, 0. So what I'm trying to do is get it as close to there as possible, and then we just say OK. Because I know on my machine I haven't got a great deal of size to do this. I can just get these 2 done. So, and then what we do the same thing on the fin. We do move, then I'm going to turn that round, something like that. If you select that option there, it's like a free move, whereas if you select these arrows, it goes by a different, it just goes by steps. So what we'll do is we'll move that over as close as, let me zoom in a bit here so I can get it as close as I can. I know if I get them really close I can just do it. If we say OK to that, and now all we have to do now, we can do it two ways. So if you have a look, we've got this sketch in here, the sketch we're working on. So I can just say finish sketch, and now I've finished the sketch. I go on the sketch and I can say save as DXF, and this will now load into OpenBuild's CAM. Now if you want to, and you're very familiar with Fusion 360, you could actually generate the G-code from within Fusion 360. The only thing with Fusion 360, the manufacturer section is quite advanced, and it does take a while to get to understand it and use it. And I found for this type of thing, the OpenBuild's CAM is a lot easier to use and more sort of aimed at the hobbyist really. So that's why we do it that way. Some things I do with the Fusion CAM or manufacturer section, but so what we'll do is we'll go save as DXF. You see I've done loads of things already. So what we'll do now is we'll save it as sheet. That'll do, sheet 1 demo. Yeah, we'll replace it, that's okay. And we can save our design here, just go on to save. And all we do now is we go and load up the OpenBuild's CAM. Now I'll put a link in for the OpenBuild's CAM, but I've got it up here on my favourites. And because I've used it before, it's got some settings already. So all you need to do here, if you're new to using the OpenBuild's CAM, I'm using generic Garble. And down here it's got my machine settings. So I've got 315 on the X, so across that way. I've got 520 on the Y, which isn't a great deal, but it's good enough for what I'm doing. And most of the other settings I've just left of default, so we just save that. And all we need to do now is bring the file in. So we go into the OpenBuild's CAM, we go open, drawing. I'm in the wrong directory here, so we go to plans, MiG-29, and we called it sheet 1, didn't we? Date modified, that's it. There we are, sheet 1 demo. And there we are, that's come into the OpenBuild's CAM. Now if you have a look over on this side here, we've just got 2 lines, and each one of them lines refers to each one of these. So you can see I've selected that, refers to the fin. If you don't do that, what you'll find is you'll end up with loads of little lines, and then you'll have to go through and select them all, and it's a bit of a pain. So this is actually the best way to do it. So what we'll do in the next section, I'll show you how to actually generate the G-code with the OpenBuild's CAM. So guys, in this next section, we get to the part we've all been waiting for, how to actually get the G-code. So we left off in the last section where we got the drawing into the OpenBuild's CAM software. And again, this software runs online, and I'm amazed at how well it does. The more I keep using it, the more little tips and tricks I keep finding with it. So I'm very impressed with it. So what we want to do now to actually generate our G-code, and I think I showed this in the last video as well, but I'll go through it again, just in case you're only watching this video. But what we need to do now is generate the G-code for these parts. So in our settings, we've got our machine size, So there's our machine size there. And what we need to do then is select these objects here in the document section, add them to the toolpaths, and then we'll generate Gcode. So what I'll do is I'll do them both together. I mean, I could select them like that, or I could select one at a time. So you might want to do an inside cut and an outside cut, which is how I did the servo hole there. So I did that as an inside cut and I did this as an outside cut. But for this demo, we just show the outside cut. So we can actually do them both together. So you can see there it says go add to. So if we select add to, so we select on that, create a new operation. So for the needle cutter, it works exactly the same as a laser cutter. So all I do here, now you can see we've got different operations here. So if you're going to make something with, if you wanted to make a wing rib or something, then you would probably select milling grouting. But and you can see we've got the different operations here. It's even got drag knife in there as well. So it's really good software, this. So what I'm going to want laser vector path outside. And if we go down the settings, we've got the safe height. So that's the height it's going to retract to, and 10mm is enough for this. Laser power doesn't really come into it on the needle cutter, but if you're using a laser, you could select your power there. And the curve setting there, that's actually this little needle that you might not be able to see there, but I'll put a close-up picture of it. That needle there is 0.6mm in diameter, so that's the same. And the feed rate, as I said in the last video, I started faster than that, and I've found that the 600mm seems to be about right for the needle. Otherwise, if you go much faster, it tends to bend the needle a little bit. So what we do then, we say, and so that's created that operation there. And if you want to, you can just click on the side there, and you can go back in, and if you want to change anything, you can even rename this vector if you want as well. Now once we've done that, we tell it to generate the Gcode. So we've now got a Gcode generated, and we can simulate it if we want. So if we do it fast, and we do a simulate, and you see what's happening there. It's giving a simulation of what it would do. And you're getting all the coordinates up there as well. So that's a simulation. Now we've got two things we can do here. Because I've got my controller connected at the back there, I can send it straight there now. It's plugged in, but it's not actually connected. So if I bring up, just go on to me, Open Builds Control. Now Windows machine is struggling a little bit here because it's got quite a lot running. It's got the screen recording. So we've got the Open Builds Control running there. There we go. And if we do a connect, makes me laugh when I see this fake on COM7. So if we do connect, now if we go back to the Open Builds cam, you can see now here, this connection has become active now. So if we do generate Gcode, it's generate the Gcode. We can either transfer it or we can save it. So if we just do a save operation to start with, and it asks you for the name, I'll just put in MiG-29. Just call it demo. Do save that. It'll ask us where we want to save it. I'll just put it into downloads for now. And then what we can do then, show in folder, Where's it gone? There we go, at the bottom there. And what I'll do is I'll open that with Notepad++. We've got the, let's take the view. I've got symbols on. I don't want any of that, do I? There we go. So as you can see there, that's generated our Gcode. So what we can do now is take that to our machine. But if, like here, you're actually connected, so if we go to, we can transfer the Gcode to the Open Builds control program. So if I just click on there, and now we're in the Open Builds control program, and I haven't got a machine plugged in at the moment. And then what we could do now is we could just go on, once we've got the machine zeroed in and everything, we could then go and actually run the code and generate the parts. So what I'll do is I'll put a little bit of video in here showing you how it did it on the previous video. It's exactly the same really. And this needle cutter, I'm quite amazed at how well it works. But this process here doesn't have to be a needle cutter. You know, you could be a laser, could be a milling machine, plasma, whatever. So the process to get the Gcode out is the same, whatever type of machine you're using. So that's basically how we get the Gcode out. Now, as you may have noticed, when I showed you this work so far I've done on the MiG-29, this is actually bigger than my machine. So you can see this has been made in parts and I've glued them together. So within Fusion 360, if you've got parts that are too big to fit on your machine, then what you need to do is split the bodies up. Now, I'm not going to go through that in this video because it would make the video too long. But if you do need to do that, have a look on YouTube for splitting bodies. So you can split the body into smaller parts like I've done on that main body section, and then just go through and use exactly the same process, and that's all I've done on here. So so that's how we generate our Gcode. So all we do now, all being well, is run the Gcode. There we go. There we are, finished. There we go, there's the cutout section. So guys, that brings us to the end of the video showing you how to get the Gcode from PDF plans. I hope you found it useful. And as I said at the beginning, it isn't the only way to do it, but it's the way I found that works well for me. You know, so if you do know of any better ways or simpler ways, you know, let me know. I'm always be pleased to hear. I did try doing various things in Inkscape to make it a bit easier, but I couldn't find a simple way. So if you know of anything, you know, do let me know in the comments. So that's probably going to be the last how-to video of this year. I may have possibly one or two more flying videos up. I'm hoping to get the MiG-29, which you've seen. Still a bit more to do with it. These sections go in here, and you see they fit absolutely perfect after being cut out on this needle cutter. So there's quite a bit more to do on that, and I have got some extra reinforcement to go on it as well. I'll just get one of them and show you. So these are some extra sections that are going on. and within there's some carbon rods. So, and I've got this bit to cut out first, but so you see there's still a fair bit more to do on it, but I'm going to do a few more modifications on it as well to make things a little bit better for it. Still got a pin in there, I think. But so I'm hopefully you get that built in the next few weeks, and that'll probably be the last video of the year. So thanks for watching, guys, and I'll catch you in the next one. Hopefully it'll be the MiG-29's maiden flight.